This is the Amp Hour Podcast, recorded September 1st, 2014, episode 214, recurring RF Remontados.
Welcome to the Amp Hour. I'm Michael Osman of Great Scott Gadgets.
And I'm Chris Gamble of Contextual Electronics.
And I'm Gregory Charvat, and I'm an entrepreneur. I built some through-wall radar stuff. I made the MIT coffee can radar, and I wrote a book on small and short-range radars, and I can't really tell you what I'm doing with the entrepreneurial stuff. Is that good?
Well, I guess. Well, why don't you just... Come on, Greg. It's been months now. It's been months.
I can't say anything, Chris. I can't. But I'm involved in a new company with the same investor right now.
Okay, that's
so.
I guess we'll have to just go with that, and we'll
have to
continue.
Go with that.
Wait with bated breath until you can tell us. But I was excited because we got Greg and Mike on the show at the same time, and we're going to talk some RF today. And
all right,
I'm excited.
Cool.
Radios.
I love radios.
So, Greg, why don't we go back a little bit in time, because we haven't talked to you since the Malaysian Airlines disaster. And
right.
You were the engineer expert on television.
I was.
What the hell was that?
Well, first of all, they should never let an engineer go on national television. Never.
Why is that?
Well, because we might. We have a tendency to jump into the details if you're not careful,
Oh, do we?
Yeah, occasionally.
I never noticed that before.
And I don't know, they kept bringing me back, which was really great. I tried. So for that reason, my goal was to kind of keep it, high level. Uh-huh. And really what they're looking for is, a 1 to 2 to 3 to 5 minute interview where you provide some insight, some high-level insight as to how the different radar sensors and things work. And the crux of the biggest problem with the Malaysian Flight 370 disaster was that there were so many different signals and satellites and radar and sonar and all of these things involved. So there's a lot of confusion as to, why can't a radar in Malaysia detect a plane all the way 1,500 miles out into the Indian Ocean? Simple things like that people don't really understand, so so basically I provided some insight, and I actually even brought on television some models. I brought a little radar dish at one point, and I even brought aluminum foil on the air, Chris.
Yeah,
nice.
I saw the video at one point, and it seemed like you were like, okay, America, here we go. Let's sit down. Let's have. It was like you should have put on the cardigan sweater and been like, hello, boys and girls. Today, the land of imaginary signals.
Well, I'll tell you what. What was happening was the conspiracy theories were flying around about that because of the confusion about the various signals. Like you had that. There's a satellite transponder thing on the plane that would provide information about the engine maintenance. Okay. And that's how they ended up locating, or rather hypothesizing, where the plane went. Then you have radar signals. You've got like the air traffic control radars. Then you've got the search radars on the P-8 Orion. And then you've got sonar, and you've got all this stuff. And you've got satellite imagery.
Yeah.
So, it kind of was ripe for people to theorize. And the first one I helped put to bed was the theory that they flew north. So a lot of people thought that plane went north up through the Himalaya mountains, which is a very militarized part of the world, sort of the border between India and China and so on and so forth. And there are a lot of radar sites. And the theory was that they deliberately dodged radar. So it's kind of like Top Gun meets a jumbo jet or something. You know what I mean? Here it is. Here's this conspiracy theory. Here's how it would have worked. It's Top Gun meets MacGyver. Okay, so you have a couple of these guys who would have flown that jumbo jet like a F-14 fighter pilot, dodging radar, which is hard to do with those planes alone. But also they would have to duct tape to the windshield of their plane an electronic warfare ELINT receiver to see where all the radar sites are. And then they'd have to be bombing up and down the Himalaya mountains doing barrel rolls, just be crazy. So I helped put that to bed. And it was funny because there's another radar guy in the New York Times who basically reiterated the same thing I did the following day. So I thought that was pretty cool. We were all sort of converging, and that part of the story, started to go away, which was great. Good. So I feel like I made some contribution to it. But it was an exciting experience because they actually send like a chauffeured car out to get you, and you go into New York City, and it's just like it's crazy, and you're there for a couple hours and back out, and they put you through makeup. That's another thing engineers aren't usually accustomed to. Yeah. Have you guys ever had makeup on before?
You guys don't wear makeup
for a long
every day?
time.
No.
No, me neither. That was my first time, Chris.
Oh, you never did like theater in high school? No.
No, I hated theater in high school. I always hated it.
Mike, you ever do?
Yeah, I did a lot of theater and stuff.
Yeah. So
did?
Me and Mike, we know. Yeah, they cake it on you because all the lights are so bright and everything.
Sure.
Yeah. Well, they definitely caked it on. Yeah.
See, now I'm wondering more about the mindset of like, was it like, if you'll excuse the phrase, here comes the nerd, or is it like, here comes Dr. Charvat, the expert? Is it like, roll out the red carpet, or is it like, we don't care because we have people coming through all the time kind of thing?
No, it was more like the later. They were, they treated me like the expert. They actually they put graphics of my book
nice.
on.
That's fancy.
National television before I went up there. It was really nice of them, and I would say, especially the CNN people were very professional. I was very impressed by them. Very like positive, happy bunch. I would say a very, like you ever go to a company, you ever visit like a vendor or something, and everyone's miserable at that company.
Yeah,
you know what I mean.
I've seen it.
And then you visit another vendor, and they're all happy to be there.
Uh-huh.
Like. These guys had one of those very positive cultures at CNN. Everyone seemed to be really happy to be there. They're very just super friendly, very supportive, and they'd tell you, "Oh, you did great."
Of course they were making bank on the Malaysian Airlines crash for like 6 months.
Yes, they probably were. I don't doubt that. The ratings went up a lot, I've heard. So, but they, it's kind of crazy. They're a very, very positive group. I think it's very interesting.
Well, that's crazy, man. That's an interesting experience. And you told me the other day that they asked you about sonar at one point as well.
Oh, so after I made some appearances on CNN a few times in the evening around the 9 p.m. slot, and then other shows. I was on ABC News this morning, and they on Saturday morning. And they wanted me to talk about the technology in general. So I had to read up on sonar and satellite imaging and some other things and just sort of provide an engineer's perspective.
Well, Wikipedia says...
Well, I'm familiar with this stuff from my previous work. So it's not, just a Wikipedia thing. But, if you want specific details about the systems that are out there, then you kind of have to go with Wikipedia.
Yeah.
Or you go with Jane's. Actually, I use Jane's quite a bit. So... which is a military kind of like a Wikipedia thing in the UK, but it's a little more technical actually. So anyway, I started talking about everything because I was providing a perspective on all the systems, sort of at the highest level. Like, what are these for? What's the satellite imaging for? What's the radar thing for? What's this for? What's that for? And then finally, some new radar data came out a week or two later, and I was invited to be on Wolf Blitzer at 6 p.m. And so the funny thing was there's no pre-interview. They just asked me to be on Wolf and they'll send a car out. So I said, okay, great. And I show up there and I assume it's about the new radar data that came out about the flight taking a turn and blah, blah, blah. And I show up and they get me ready and so forth. And I'm on and I'm just waiting there. Okay. And I'm sitting there waiting and the lights are on and everything. And they're interviewing. Okay, the next person we're bringing on is a radar expert. And then they said someone else's name, not mine.
Really?
Yeah.
Oops.
So they interviewed this other guy about radar. And I thought, wait a minute, I'm the radar guy. Like, what the heck happened here? So I just sort of, at that point, you just need to kind of go with it. So then after they were done talking to that person, they said, and here's our sonar expert, Greg Charvat. And the cameras went on me. It was live. All this was live.
Wow.
I imagine just like looking really nervous and just being like, beep, Beep. Beep. That's what sonar is. Beep. Beep.
It's acoustic.
That's
You know how you
man.
could put your head in a swimming pool and you could hear things? So anyway, that happened, but fortunately, because I was on the ABC News show talking about all the sensors, I was read up on the sonar sensors that they were going to use out in the field. They had already been televised. They're going to use this type and that type and blah, blah, blah. So I was able to basically answer some very high-level questions about those devices, and it went all right. And they're happy with that. But I was really, man, you can't really stop and say, well, wait a minute, Wolf. Wait.
Can we cut? Can we cut? Is that cool?
You can't do that, man. But if you know a little bit about it, then and you could talk truthfully to it, then it's fine. And so then I started kind of watching for that with all their other experts, and I noticed they do that routinely. They always ask people who aren't the expert about something else.
Yeah, because they just think expert is a column, right? It's just
yes,
you know everything, so answer it, man.
So if you're going to be on TV someday, Chris and Mike, you'll have to answer just about everything. Just be ready.
It sounds like so much fun.
Have you been on TV, Mike? I don't know.
A little bit, but not a lot.
Yeah, like what kind of stuff?
Yeah. Mostly I've been on things like podcasts like the Amp Hour more than I've
so
been
not TV then. Okay,
more than I've been on TV. Yeah. I have a thing coming up, but I don't think I can really talk about it yet.
Oh, okay. Well, I will be asking you afterwards.
Yeah. I'm intrigued. It must be one of those reality shows about the genius inventors building something in a short period of time.
Oh man, I have so little interest in doing anything like that.
I know they keep coming out with those too, and it's just like, I mean, you talk to Joe, so Mike, you probably know Joe Green as well, right?
Yep.
And Joe talks about that a lot, and it just seems like the worst experience. And obviously Joe's been on the Amp Hour before, but it seems like just the worst experience because it's the same thing. It's like, oh, you're an expert, just build this. Just go build something. It's not a big deal. Well, screw you, producer.
Well, those shows are brutal because I don't know. That would be tough, I think. Plus, they've had a few of them where people are doing them, they're on the show for a long period of time, like 6 months or so.
Mm-hmm.
And I mean, I wonder if I'm not sure you'd be able to find the best electrical engineers or engineers to be on those shows because everyone else, in 6 months, I mean, you can make a lot of money in your career in 6 months.
Right. Yeah, unless they're paying a buttload. Yeah.
And they don't pay that much usually. That's
right. They pay in fame. Right. Well, and that's the other thing. Like, so I don't know if you guys saw, like the Mythbusters, they just changed their format, and Grant and Tori and Carrie are all booted off. So that's
I heard about that,
really?
but I haven't seen it.
Well, I think that's because it's a new season coming up where they're going back just to Jamie and Adam, but like thinking about when MythBusters started, right? Like that was 10 years ago now. Mm-hmm. You think 10 years ago in the cable landscape, there actually was enough. I mean, it's not like it was the big three where it was like ABC, NBC, CBS type of thing, but it was like, it was at least enough of a consolidated cable access where, Discovery Channel still was one of maybe 100 basic news or basic cable channels, at least in the States. And nowadays there's like, there's like 700 channels, there's YouTube galore, there's all these different things. And it's just like, I don't even know how that would work these days. You'd never get paid for it. And you never have a big audience either. If they say they're going to pay you in fame, they're lying through their teeth, right? There's no way to guarantee that.
Plus, I mean, if you want to stay in the headlines or what, if you want to be famous, I mean, you really got to you have to have lots and lots of content out there nonstop, and it all has to be in big impact stuff. I mean, it's a marathon, it would seem to me.
Yeah, well, we see Dave. I mean, obviously. Oh, we should mention Dave's not here this week. If people didn't notice, the lazy Australian's on another vacation.
I thought he was sitting in on this meeting here.
Oh no, yeah, no. He's usually so quiet. He's like Teller, right? You know, of Penn and Teller.
Oh yeah,
he never
that
says
characterizes
anything.
Dave exactly.
Yeah, exactly. No, but he's on vacation this week. But I mean, Dave's a good example of that. Where like I think he just put out like 650th video or something crazy like that. So
Now, does he pay for his? Does he put food on the table with YouTube views, or how's that work?
yeah, he does. Yeah,
Wow, man, you got
some of it, but it's such a long time.
Yeah.
So, but I'm more interested about people starting into the video scene. And let's hear about Mr. Osman here. What is Mike? What's your deal with your new video series? I posted about it in the subreddit the other day.
Oh yeah. So I just so I'm joining the club.
Yeah,
doing instructional online videos, and it's been a lot of fun so far. It was a long time coming. I've been kind of working on setting the stage to do this for about a year now.
Yeah.
And finally sat down and started shooting, and kind of had to throw out everything I thought I had figured out about my video editing and so forth. And finally, got some stuff working, and I've posted 3 videos so far. I'll be doing a 4th very shortly. And
could you tell people what it is in general as well?
Good idea.
Yeah.
I'm doing an instructional video series on software-defined radio. So
Ooh, that's cool, man.
Yeah, it's cool. It's something that's been missing, I think. Like, people are always asking me for a good book to recommend on software-defined radio, and there just isn't a good book that's like introductory at the level that people want, and is also practical, kind of hands-on stuff, and not just theoretical math. And so I'm trying to. And so I've tried over the last several years to fill that void with an in-person 2-day class that I teach, and it's a really intense class. I mean, it's a lot of information in 2 days, and it's a lot of fun, and people really like it, and I enjoy teaching it. And I thought, well, it'd be nice to kind of bring that to a wider audience, and in particular, people always ask me like, "Hey, can I get like your slides or your teaching materials from the class?" And I'm like, I'd love to publish that stuff, except it's mostly just me and a whiteboard. It's like,
yeah, right.
I don't have this stuff written down. I don't have slides. It's all hands-on exercises and me at the whiteboard. So I finally decided to do this as an online video series and try to capture all the stuff that I teach in my in-person class, put it into an online video series, and hopefully it will eventually as I add more content, it'll eventually encompass even more content than my 2-day class.
So what about the level of people? So that's what I always wonder about, like when people are starting this kind of stuff too. Like so when people show up to your 2-day class, or do you have any like prerequisites of like, well, you should probably know math or programming, or you should have this software, that kind of thing? Like what is that usually? And actually, where are you? This is usually at like TourCon and like
So I normally
stuff.
teach at information security conferences. So most of my students have been security professionals, and they'll mostly, probably 80% of the students in my class have a fair amount of programming experience, and a lot of them do pen testing or other security research, or it's a highly technical group, but generally people who don't know much about radio or digital signal processing. And so that's kind of the folks that I try to target, is people who, like, you don't have to be a computer programmer, you don't have to be into security at all, but you do have to be somebody who's kind of good at making computers do what you want them to do. And if you're in that category of just kind of a person with some general technical knowledge, some general computer knowledge, and you don't necessarily know anything about radio or SDR, then you're the kind of person that I think could get a lot out of the course.
Is it a project-based course, or what? How does it work in 2 days?
So in 2 days, I do a whole bunch of hands-on exercises, and then some lecturing and group discussion and stuff in between. In a video series, I'm breaking it up into pretty small chunks. Like I think my longest video so far is about 40 minutes, and my others are under 20 minutes. And then with each lesson, there's a homework assignment. So, and it's been actually really cool seeing people. So a lot of people have been talking to me about their homework, and people are actually doing the homework, which is outstanding. And I try to make the homework assignments kind of fun and interesting. So I try to keep the boring parts of the content into the videos, and then let people explore the more exciting stuff on their own. Hopefully, I don't know. There's a little bit of a balance there, but in general, I try to not actually do anything that's boring. I think it's a very exciting subject, and I think that if it's presented correctly, it can be exciting the whole way through.
Well, it's interesting too, people coming from the software side going towards the physical world, because I think traditionally, as the field of SDR is developing as well, right, as people that were probably hams that were getting into the digital modes and stuff like that, moving the other direction, moving towards the programming side, and now there's people going the other direction now, like with this stuff, and it just basically brings new stuff to light, and new ways of teaching and new ways of learning, that kind of thing.
I think that's true, and to some extent, and it's similar to the way that we have this hobbyist electronics renaissance these days. That so many of the people getting into electronics now are people who do have a computer background, and it's the same kind of thing happening with radio. SDR is kind of where radio and computers meet, and people can come at it from either direction, and kind of microcontroller hobby stuff is where computers and electronics meet, and people can come at that from either direction.
Do you, for your homework assignments, what is there a radio platform you use for the class, or how does that work? How do you?
Yeah, so HackRF is my own platform.
Okay.
And so I'm calling this series Software Defined Radio with HackRF, because that's kind of the preferred platform for people to use. But you don't have to have a HackRF to use to go through the class. You can really do a lot of the exercises with other SDR platforms, and some of the class you can even do without having any SDR equipment, and just learn it through simulation, or and just learn the theory and the computer side of it, without necessarily having to deal with real world over the air signals. Mm-hmm. So I try to make it as accessible as possible to people who have varying hardware available to them, but the kind of the base assumption as far as what I will include in the class is that most people taking the class will have a HackRF, and that's kind of the what I'll build the exercises around, is that assumption.
And Mike, remind me, the HackRF 1, so that's the one that was the Kickstarter one, right?
Yep.
That is all shipped now, or in the process of shipping? People can get one, or what's the deal with that?
That's shipping now. All the Kickstarter rewards have shipped, and just within the last week, I've shipped all of the pre-orders to resellers who were taking pre-orders. So they're starting to ship those already, and probably all the pre-orders will be shipped to the individual buyers by the end of this week.
Wow, that's great, man! Congratulations.
Yeah, thank you. It's very exciting.
Yeah, and I got to. So I met Mike at at DEF CON. I got to shake hands with him and talk for a little bit. I got to see the actual Hack RF in the new case too, and that's a great looking case. It's like it's a unibody case, right, with like the end caps on it. And then
actually, it's a two-part injection molded snap together case.
Oh, yeah. I thought it was a unibody. Okay.
No, but we didn't have long to look at it.
I didn't throw it on the ground. That's the way to really test it.
Oh yeah, it is definitely. Yeah. Sorry, we didn't get more time to hang out at DEF CON. That was a crazy busy time for me.
Yeah, that's okay. I expected that. So, Greg, what about you? So, Greg, have you ever done the SDR side of things? Are you into that stuff? Because we obviously know that you're into the ham side of things. Is this ever crossed your path?
I've never tried it yet. I think all of my radar stuff is in effect software defined. Yeah. All my radar is all digital. Everything is. It's all about digitize as soon as you can without providing a lousy signal to digitize. Let's put it that way. And this is cool. I'm looking at the Hack RF 1 right now. I mean, what FPGA did you use on that?
There's no FPGA.
Really?
Yeah, which is one of the reasons that it was able to meet the my requirements were to make it very low cost and low power.
Yeah.
I wanted to run off of a USB 2.0 port, and operating over a very wide frequency range and at as high bandwidth as I can over USB 2.0 made it very challenging to meet that power requirement. And so one way I was able to reduce cost and power consumption is just to go without an FPGA. There is a small CPLD on it. It isn't enough to do DSP, but it's a little bit of logic, a little bit of glue logic that lets us do things like convert an unsigned int into a signed integer, that kind of thing. And then we have an ARM on there, and it's an ARM Cortex M4 that has some DSP instructions. So you can do some DSP on board, but the primary use case that it's designed for is plugging it into a laptop or another PC that modern PC CPUs are just incredible in their in their ability to do signal processing.
That's right.
Based on that availability of that power that people can plug in, I thought let's just see how it goes without an FPGA.
I think that's the way to go, is to try your best to avoid the FPGA. I mean, they're an enormous amount of time commitment to make them work properly.
Yes,
they really are. This is wonderful. I know that at some of my friends at MIT Haystack Observatory, they field large field radio telescopes and phase array radar systems. And their unofficial policy is to no longer use FPGAs.
Really?
Yeah, they're just it's just too much work. These guys field a system in 12 to 18 months. They don't have time to develop all the FPGA stuff, and deal with all the bugs and blah, blah, blah. So they just don't. They stopped. They can't afford the time anymore.
They just need to get better VLSI designers, right?
Yeah, an army of them if you want to go that fast. Yeah, that's just it with these things. I mean, it's you use them if you have to do some pre-computing, and you're running a lot of bandwidth. That's when you have to use them, but you don't use them if you don't have to. That's kind of how a good designer approaches things. And I think, Mike, by avoiding one here, I am just very impressed. Hats off to you, my friend.
Oh, thanks.
This is wonderful.
It was a tricky design decision because, obviously there are tremendous advantages to having an FPGA.
Yeah.
But, I've been looking at how people use software-defined radio platforms for a while.
They never get into the FPGA. It's too much.
It's very rare. Yeah. So even if you have a nice platform that has an FPGA that has a whole bunch of DSP capabilities that you could use, it just seems that 90% of the people who use those platforms never really use those capabilities.
Probably north of 90%. Everyone pretends like they're going to use it someday.
Right.
I love Xilinx.
Yeah.
It sounds like such a good. It sounds like such a good solution for so many problems, and it really is. It's just that big that big hurdle that people have to go through to actually put it to use.
Right. And oftentimes you're debugging the code, the system for the manufacturer as well. I mean, it's not well developed. You try to do anything with these, and it gets all messed up, and you have got to have a really good FAE, a field engineer involved. And you need to, in order to have a FAE involved, you got to be a big player. That's kind of it with FPGAs. I mean, so Chris, to answer your question, it's on my to-do list to do some software-defined radio stuff. All my radar stuff is software-defined, I think, by definition.
Yeah.
But this is something I want to do eventually.
Well, we haven't heard about any work you're doing, so obviously you have time to do this right now.
Well, did you know I have a 4-month-old daughter too now?
I did. I knew that, yes, but now everybody else knows that as well. And you just got a new place and you moved, and so sounds like you don't have much on your plate, Greg. I'm just saying.
Someday, so when I do jump into this, I'm getting Mike's board here, which the HackRF one or whatever one that he recommends, and I'll take your course. I'll just come up. I'll show up for your 2-day course. This is just
That'd
awesome.
be a lot of fun. I would love to, at some point, experiment with kind of combining the coffee can radar with HackRF.
Oh, dude, you should do it.
And doing, wider bandwidth stuff than you're able to do with the sound card.
You should do it. What that would buy you is you can chirp it faster and go further range. So what you could do if you merge HackRF with the coffee can radar, you could do range Doppler imaging in real time.
That'd be neat.
That would be super.
Wait, so actually, I have a question about that. So we're talking about FPGAs versus like kind of repetitive processing of stuff, right? Or capturing and then doing it on the computer. Does that mean, Mike, is that the HackRF...
This is streaming. It's not capture. Mike's streaming, man.
So that's the question I was going to have. Is it real time? I mean, like, can it actually do that, or...
Yeah,
remind us the bandwidth limits and stuff.
So I don't really have much of any memory on the board itself. It's the goal is basically to get samples in and out, to get a waveform in and out between the host computer that's connected to and through the antenna as fast as possible. So my primary limitation, and the limitation that HackRF 1 is designed around, is the maximum speed of high-speed USB. So that basically is what dictates my sample rate that I can operate at. I'm using 8-bit samples, and they're quadrature samples, so there are 2 8-bit samples every sample period. And so I'm getting a pair of 8-bit samples 20 million times per second, and that pretty much maxes out high-speed USB.
Yep.
And so so the rest of the board is kind of designed around that 20 megahertz bandwidth limitation that comes from the USB interface, and that kind of works out pretty well because finding other parts that could go much, for other places, either digital or analog, through the signal chain, finding components that would really do the job much faster than that end up being a lot more expensive. So it turned out to be a pretty good threshold where 20 million samples per second, or 20 megahertz of bandwidth, is nice and fast compared to a lot of the other options that are out there, like TV tuner dongles are almost 10 times slower than that. So it's nice and fast compared to a lot of things that are kind of in the same price range, but it's slow enough to not break the bank.
Question for you, Mike. So if one way that would really be great for using these things for radar would be if there's some way by which we could trigger.
Yes.
So do you facilitate that? Because when I've looked into these things, these software-defined radio boards in the past, is that there's basically no way to trigger it without diving into that black hole of work known as the FPGA code. It's not code. It shouldn't be called code. That's not a fair assessment of those people who actually design those things. But that aside, is there a way to trigger this one? Triggering would be great for radar stuff. Yeah.
So one of the things that I really tried to do with HackRF was make it as hackable as possible. And it's open source hardware, and I tried to kind of break out everything I possibly could from all the different chips on board into expansion headers and so forth. Mm-hmm. So there are lots of expansion options into the ARM microcontroller that controls everything on the board. There are lots of expansion. There are a number of expansion pins for the CPLD, and there's also an expansion header for the baseband analog signals. So you can directly kind of get in between the RF section and the ADC DAC. So you can potentially implement a trigger. The easiest way to implement a trigger would be with one of the microcontroller pins and use like an interrupt on the microcontroller.
Yeah.
But then other things you could do would be like to implement, if you needed more precise timing than the microcontroller could give you, and you wanted to like compare the an incoming waveform with some trigger signal, like with per sample resolution, you'd have to integrate that into the baseband header somehow and do it in kind of an analog trigger.
Oh man, if you can make this thing though, what it needs for radar stuff would be great to have a trigger natively in there, so you can choose the streaming mode to be triggered or non-triggered, or triggered with so many samples, and then it waits and then streams the next batch that comes. Something like that would make these work great for radar, because a guy like me has to be able to do it. I couldn't jump into the microcontroller code.
So what's the give me an example of how you would use the trigger?
Well, it sounds like almost like a oscilloscope. It sounds like how you're explaining it, right? I mean, like, so you say trigger, it hits the trigger point, and then it has this huge capture, and then it crunches on. Is that right or no?
Yeah, and then it just sends the capture along, and it can start sending it right away. But the trigger is absolutely key. In any radar system, what you're doing is you're clocking the speed of light. You're clocking the time at which you emit a wave, and it bounces off something and comes back. You're clocking that round trip time. So you have to very precisely know when your transmitter fires.
Oh, gotcha.
Or begins. And if we consider the case for the coffee can radar or any ultra wideband linear FM system, you trigger when you start to up ramp. And that's essential to being able to do really fancy processing like range Doppler or synthetic aperture, or good high SNR ranging.
Mm-hmm. And remind us what is the frequency range of a lot of like the coffee can and other stuff that you work with?
So the coffee can is 80 megahertz of bandwidth. It's fairly wide band.
What's the baseband though on that?
Baseband is 20 kilohertz, or I think it's actually 15 kilohertz. So, but what you do in the coffee can radar is you multiply your wideband chirp waveform by whatever you're receiving in real time in the frequency mixer. So then you only sample a small bandwidth of that. So you amplify the product of that multiplication, and you filter it so you don't alias your sound card, and that's what you're processing on. That's what you acquire.
Oh, and that's the capture mechanism right now is sound card, right?
Yeah, it's not a great way of capturing it, but it is a way of capturing it. And so the right channel is the product, and the left channel are the synchronization pulses from the ramp generator. Mm-hmm. So you capture when the ramp generator fires, and then what we do is we just record and process offline, and what we do is we do some interpolation on the left channel to find out exactly when it fires. It's really not a great way of extracting good timing information. If you merge a coffee can radar with like a National Instruments DAC card or something that has really good triggering, then the thing starts to really perform.
Yeah, I've been thinking about a couple of different ways to do similar things with HackRF, and the obvious way is to use two HackRF, since it's a half duplex transceiver, so we could transmit on one and receive with the other.
Mm-hmm.
Do you have to tie them together then? Is that like physically tie them together? So you actually transfer
synchronize them.
Yeah. Okay.
Mm-hmm.
And then and there is clock synchronization capability, but the perhaps the more interesting approach would be to actually like make a little add-on board for a single HackRF, because you really only need one SDR.
Yeah.
And then the transmit side, the chirp generator, could just be like using your existing design or something similar to it from the coffee can design, and then have like a little add-on board that synchronizes to the main board and does the transmit part.
Yeah. You know what you could do with that? Even if you were to simply output a TTL line that goes high when your HackRF starts acquiring, that's fine. If you export a trigger, that's just as good as importing one. Radar systems can work around that. A radar can export or receive a trigger.
That's a good idea.
Yeah, and that would cost nothing to do.
Yeah. And another way, of course, would be just to ignore it, just completely bypass the whole RF section of HackRF and just use the baseband section.
Yeah.
And basically plug in like your existing design to the baseband, and it would just be like your existing design, except with a much higher sample rate than you get off a sound card.
That's probably what I would do. And the neat thing here is what sample rates buy you on chirp radar systems is you get a larger range extent. So with the coffee can radar, it chirps in 10. It's a 20 millisecond chirp. So that's how long it transmits for. And then because we're band limited to 15 or so kilohertz on the audio input port, I think we have about 100 meter, 150, somewhere between 100 and 150 meter alias-free ranging. So if we increase the sample rate, then we could make the range out to a kilometer, because the thing can actually see 10 dBSM car-sized targets out to a kilometer.
No kidding.
Yeah, and then if you at the same time you could increase the chirp rate. So instead of every 20 milliseconds, it's every 1 millisecond or 500 microseconds. So then you could see the whole kilometer, then chirp really, really fast. And now you can do range Doppler imaging of everything within a kilometer, and that would be cool. So
can you explain that a little? So I'm sorry, I don't understand this stuff, Greg. So you're saying, like, okay, so you send a chirp, and the idea is that you send that chirp, and you're measuring how long it takes to get back to you, bouncing off stuff, right?
Yeah,
and then but you send multiples of it.
What you do is you just chirp over and over and over again. So you basically the ramp generator is just a sawtooth generator, and it's fed into a voltage controlled oscillator. And then the voltage control oscillator is amplified and radiated out of the transmit antenna, and it's radiated towards the target scene.
And that's why it's called a chirp, because it has that increasing frequency, right? And that actually covers the whole.
Yep. Yeah. It's a time. Yeah. It starts at one frequency, ends at a higher frequency, so it's low, ends high.
Yep.
And what you're doing is, at the same time as you're radiating those chirps, you're receiving everything on the second coffee can and multiplying it by what you're transmitting with right now. So you're multiplying the transmit chirp with delayed chirps coming from your target echoes. You see what I mean?
Right. Okay. Yeah. And then that down converts it, because it should be, that aliasing is what down converts it, basically, or whatever.
It down converts it right away. So let's say, for example, you have a target that's 10 feet away. What it'll look like is, that's a 20 nanosecond round trip. So it's 10 nanoseconds out to the target, 10 nanoseconds back, because the speed of light is 1 foot per nanosecond approximately in free space. So what'll happen is you have a 20 nanosecond delay in what you receive. You receive a chirp that's delayed by 20 nanoseconds in the second can, in the receive can. And you multiply that delayed chirp by the chirp you're transmitting with right now. Now, bear in mind, your chirps are 20 milliseconds long. They're huge. So you're always transmitting and receiving at the same time.
Yeah. So
you're multiplying one linear chirp by the other linear chirp with a slight time delay. What's the product of that multiplication? It's a sine wave.
It's just a low frequency sine wave.
A very low frequency sine wave. In this case, something 10 feet away might be 1 kilohertz. So you see little 1 kilohertz, you see 2 or 3 sinusoids at 1 kilohertz. Then you move the target back further to 20 feet, and you see something at 2 kilohertz. And you move the target back to 30 feet, and you see a 3 kilohertz sine wave. And so you have something. Your data is really a sine wave whose frequency is proportional to range to target. And that's, if you ever hear PhD signal processing guys you must be one, or you're familiar with them.
I know some.
Yeah.
Yes.
Whenever you hear those guys talk about spatial frequency domain, that's what I just described to you. Spatial frequency domain. So that's all there is to it.
So tell us about what the benefit is to doing increasing the chirp rate.
Oh, that's a good question. So you get more looks in time. So right now, the 20 millisecond, every 20 milliseconds I chirp, I'm only, I don't know, 50 hertz, 60 hertz, something like that. So I'm only looking, 50 times a second or whatever it is.
Mm-hmm.
If I have a 1 millisecond chirp, I can look 1,000 times a second.
Yeah, your resolution goes up, right? Your spatial resolution.
Well, your spatial resolution, here's the thing. Your spatial resolution depends on how much frequency you chirp. So it doesn't matter whether it takes 100 milliseconds or 500 microseconds. It's the same. But here's the other dimension that we haven't talked about yet. Your Doppler resolution, your ability to resolve Doppler improves.
Okay.
So, if I'm sampling 50, if I'm blowing 50 chirps a second out there, then I can only sample up to 25 hertz of Doppler. Okay. But if I'm sending 1,000 chirps a second, I can resolve up to 500 hertz of Doppler. And at S-band at 2.4 gigahertz, that's all the Doppler you're ever going to see. It's a pretty big wavelength. So, if I can go to 1 millisecond chirps, then I could do range Doppler imaging of things. And what that looks like is this: if you Google or go to YouTube, look up range Doppler imaging. They do this, fighter planes and all kinds of sophisticated radar systems do this all the time. It's a way of locating and identifying and differentiating targets. So if you have like a Mercedes that's going 90
and then the
miles
government
an hour,
shows up.
No. So if you have like a Mercedes that's doing 90 miles an hour on the freeway and you see it with your coffee can radar closing at a kilometer and coming in, it's going to have a unique Doppler signature, and you'll see this target that's 100 kilometer away, but out to the right by 250 hertz. And then it's going to have a Doppler spectrum associated with it because the wheels and different, if it's got spinners, it's got dubs on it, or you know what I mean? And then when I drive my Ford Escort down the road at 70 miles an hour, that's going to look different. So I might be.
Come on, Greg. We know you can't get up to 70 in that thing.
We might be at the same range as I could be at the same range as that Mercedes, but if I'm driving 70 and he's driving 90, we'd show up as two distinct targets on the range Doppler map.
Oh, wow.
So it's a really cool thing. It allows you to see everything with just one pair of antennas. No scanner, no dish, no array, just one pair. So it's a very powerful tool. So if you want to use small radars for unusual or different applications or consumer applications, one of the first things you're going to want to do is range Doppler imaging. So you can use a rudimentary radar sensor and get all kinds of capability out of it. And there are a lot of $5 radar sensors out there right now that are analog in, analog out, just like the coffee can radar. And they need something like Hack RF behind them to support them.
Right. Yeah, I've been playing with some of those lately.
Yeah.
And I've just written down, buy Greg's book.
And everyone should write that down. Buy Greg's book,
should.
buy a Hack RF one.
They should.
Those are the two things that we've learned today. Buy. Buy now.
I've been playing with some just like CW radar modules, like these $5 modules that you can buy.
Yes, I have those too.
What's the name of one of those, Mike? I mean, just forget it.
I don't even know if there are any name brand ones yet. There's
a Chinese company that some Chinese guys make those. They're on eBay all the time.
Yeah. Oh, yeah. Totally on. Like if you go on eBay and you look for Arduino radar, you will find tons of these things.
No, I've got better ones for you, Mike, that I want you to play with. Hang on a second.
Okay.
I'm going to send. I'll put something in. It could be in the show notes. I wrote an op-ed for Circuit Seller recently on the future of small radar, and there's actually a European company that makes FMCW 24 gigahertz radar sensors for $5 that are better than those Chinese Doppler ones, Chinese-made Doppler ones, and they're really good. In fact, I have a few in my lab, and they're outstanding. And I'll send to Christy. You can put it in the show notes. And I'll tell you what it is in a few minutes after I look it up.
What is FMCW? Well, I'm sorry, I don't know these.
FMCW is. I'll answer this while Greg looks for his.
Thanks.
FMCW is the process that he was talking about of chirping or modulating the frequency.
Yeah, FM is frequently modulated. Okay.
Yeah, so like I was saying I've been playing with these CW radars that just sends a constant carrier that's unmodulated, and then you can get measure the return signal. But when you chirp the frequency or modulate the frequency over time using FM, that's when you can use the technique he was talking about like mixing and getting that low frequency that tells you the distance and It's a much more you can get a lot more information without really increasing the complexity of the radar very much.
Yes.
Has anyone used those that baseband signal as like a theremin type thing? I know it's really trite, but
You could
it
totally
seems
do
like
it.
it would be. Yeah,
It's
like 1
easy.
kilohertz.
Yeah.
And you could
I
do it
think
with Mike's software-defined radar thing or
Sure.
receiver easily.
Yeah.
I found it, Mike. It's
Did you?
called. Here it is. You got to write this down, okay?
Okay. I got my pen.
All right. The company is RF Beam Microwave, and the radar is called the K-LC1A.
All right.
And they're sold out, folks.
Yes. These things are $5. I know
Yeah,
they're
$5,
very
that's-
capable, right? They're basically exactly a coffee can radar, but a much smaller form factor.
Huh. That'll be really interesting
So-
to check out.
So you're gonna update is the kit gonna get updated? You think eventually, Greg, or because that I mean, not for nothing, that kit's kind of pricey.
Well, there's a few ways you
$600.
can get the kit. So there's a company that makes it in Rhode Island. The company, your Warwick, Rhode Island, Quantum Microwave. They sell the one kit for $600. Then there's
Yeah.
one that MIT Lincoln Labs makes, and they give away to all of the students. And then there are just a couple other people making their own versions of it. UC Davis had a senior design capstone group that made a Arduino Shield coffee can radar.
Oh, cool.
And then Tony, our friend Tony's trying to, or almost done making his Arduino Shield, which he intends to sell. The UC Davis folks
Yes.
will not be selling theirs, but Tony will be, and I expect his to be
Yeah.
fairly inexpensive. So
Right, Tony Long, who's been on
Tony
the show
Long.
as well.
yeah,
And,
so go to
how
Tony
we met
Long.
Greg,
That's where
so-
you're going to find the lower cost one.
Yeah, Tony was doing a lot of regulatory stuff because if people think about it, right? I mean, so like even the stuff Greg was talking about, you think about being able to detect different types of cars, eventually different types of aircraft, that kind of thing. There are actually, and if Dave was here, he'd be like, blah, 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 blah. But there are export restriction type things. They are ITAR controlled, all that crap. That's, I'm not a huge fan of it either, but, Tony doesn't want to go to jail to sell someone an Arduino Shield, so makes sense.
Right.
You got to get that stuff cleared.
Hey, he had no problem clearing it, though.
Yeah, I saw him at Maker Faire. Got to talk to him for a little bit, so yeah, I'm excited to see that stuff. That's good.
All right, I just sent you the show notes, or on email, I sent you a link for the show notes if you want to include it. I have a little op-ed where I talk about this low-cost radar device.
Yeah,
So that's valuable, and if anyone wants to kind of read about several examples of small radars in use already, I have this belief that or vision that I think we're going to see them used quite a bit more in consumer products in the medium term.
So what's an example of that? I mean, I've been reading about some of the radar stuff, like talking about like the new cars, like driverless cars type of stuff.
Yeah.
But what else are you gonna think we'll see it in?
Well, I think they're going. One example is at MIT Media Lab. There was a group who basically, I think they must have used old coffee can radar parts, and they built a 2.4 gigahertz radar set and integrated it with a video game system so that it could notice your gestures and your position inside of a small room, and then if you're in rooms that are separated by drywall, it can actually track your position throughout all of the rooms. And so the idea was that maybe you could use that for an interactive gaming system. So I would expect these things to be used in gaming systems for sure at some point. And then there's that one company, the Internet of Things company I talked about in the last show that they're using them as parking
the
sensors.
parking guys. That's right.
And they work quite well for parking sensors.
Yeah, that's definitely an interesting use of it.
Yeah, and I think too, you see them, people are doing some gestures work with them now because you can, with those low-cost Chinese-made ones you find eBay that Mike was talking about, those will give you, if you process them correctly, you can do real-time Doppler processing. So you can watch Doppler spectra. You could actually differentiate gestures and movements. It's pretty cool.
Yeah, that's cool.
Yeah, so you let some software guys loose with that kind of data, they can do some cool stuff.
Yeah, and especially, I mean, I guess they already have some gesture stuff with IR, right? And I guess if you start layering all these different other sensors on top of it, it could get, you get multiple depth perception type things. And
well, the gestures problem is exactly what you said. It's a lot of people view it as, and I think this is the right way to look at it, is kind of like get as much data as you can from as many sensors as you can.
Yeah, and that has designed in markets then too. You make better Microsoft Connects, right? And better whatever else, robot systems and targeting for old people and
or your cell phone. I mean, like if you
Yeah.
want to stop ringing, you just like brush it off. You know, fling your hand by your cell phone, have it stop ringing.
brush your shoulder. Yeah.
Yeah, exactly. That'd be cool. I mean, that's worth a $5 radar sensor. In fact, that $5 radar sensor we were just talking about, the FMCW one from RF Beam. I mean, that thing, I don't know what's in it, but I'm pretty sure there's this 24 gigahertz low-cost chipset that's out there, and I'm pretty sure what's in there is that chipset. So if that thing's $5, then if you just bought the chipset, it's got to be, I don't know, a couple bucks or less of dollar, probably.
Right. So that brings up an interesting question. So someone actually asked this on our subreddit of you as well. What about like FCC type certification for this kind of stuff? So if someone put that chip into a cell phone, I mean, does this change FCC certification type stuff, or how does it all work?
This radar's in the ISM band, so it's clear to be used.
Oh, really? Just because it's free? So why?
I don't know why.
You can get away with a lot more anyway in the ISM band.
So like, is that like a for now kind of thing, or?
It's about power. So these radars that we're talking about, including the coffee can radar, are very low power. Mm-hmm. And they're able to go out to long ranges because they use pulse compression. They use linear FM, and they use the Fourier transform. They send long pulses. So these are super low power radars, but we make them capable because we use software-defined techniques to process the data.
Okay.
So yeah, they actually are so low power, you're gonna have a hell of a time even picking them up 20 feet away if you try.
What is low power?
Oh, input power to the antenna on the order of a milliwatt or less, with an antenna that might have, 5-10 decibels of gain compared to isotropic. That's low power.
Yeah. That's great. And that kind of sounds like so we had talked about on the show, I think one of the times when Mike was on, we were talking about the NSA playset stuff. And since then, some of that stuff, Mike, you had been working on the playset stuff with the group at DEF CON, is that right?
Yeah. So I gave a talk at DEF CON, and we actually had a whole big group of people. I think we had several different talks at DEF CON, different people who did different parts of the NSA playset, which is an ongoing project to kind of show people how we can build tools similar to the gadgets the NSA uses, that kind of thing, and show how this stuff can be. It's not rocket science, and can be built with open source hardware and off the shelf tools, and we can do all the same capabilities. And the area of research that I've been focusing on, and this is actually the reason that I've been playing with CW radar stuff lately, is making RF retroreflectors, which are these kind of bugs that are implanted in either in a room or in a device, or on a cable or something like that, and then
or an iCloud,
or
topical reference.
You hit them with a radar and measure the return, and by analyzing that return, you determine what data were being transmitted across that cable, for example. And it's a way of, it's basically the same type of technology, the backscatter communication that's used by RFID systems, like UHF RFID systems in particular. So you transmit a signal at the device, and it modulates the reflection, and then you can analyze that reflection and figure out what data you're trying to tap with that device.
Right, and that sounds like that the parking. That's what you said, right, Greg? The parking system thing was retroreflector based.
Oh no, it's actually they place these radars in little waterproof pucks that are disposable, that are glued to the street.
Oh yeah.
And they
so they're active.
Yeah, they're active, and they have a battery. They've got a UHF comm system, and then they've got a radar and another sensor, and they have a spread. They've got like the spread spectrum comm standard that they created just for these things, just for this one company, and they're really sophisticated. And you throw away the puck when it dies. It lasts for 5 to 7 years.
Yeah, you talked about that on a previous show, I think.
Yeah, it's really cool stuff, and they're not mesh network. They actually have nodes that are hooked to a 4G or 5G or whatever it is, cell phone. And the node is solar powered. and then they're on schedule. So because it's all about battery life, and they talk to the node on schedule. It's a pretty cool system.
Yeah. I thought that you said that was retroreflector at that point.
No. But I have an idea for Mike here on his retroreflector project.
I was hoping you would.
Okay, so because you're using those crappy...
The Amp Hour Labs.
Yeah. Because you're using those crappy Doppler sensors from eBay, I want to get you off those and get you something good.
Well, I'm actually not using those anymore.
Okay, because those...
But I still want to know your suggestion.
All right, so what I would do, Mike, is order yourself a surplus police radar from eBay.
Oh, yeah, I have one.
That's all. That will do the trick. Okay, good. Because you're not going to get any results from those crappy little Doppler radars. You need that thing. You need something with some directivity. A little bit of
so
power.
what? Just because of the antenna array and the battery on it, or the amp on it, or what?
It's the game power app.
Yeah, they have terrible antennas. Those little units. Although one unit
You're being too kind, Mike. Terrible. You're being too kind. I was going to say shitty, but you took the words right out of my mouth.
One unit that actually is very, very similar in design to those cheap CW radars, but has a little bit of a better antenna is the Hot Wheels radar gun.
Yeah.
Oh yeah.
And I've been having a good time with that.
Those aren't those at 2.9 gig or something like that, or S band?
They're at 10 and a half gigahertz.
They're at 10?
Yeah.
Ooh.
Yeah.
Wow.
I know. So those are fun. And but what I've been doing lately for my retroreflectors is just using 2 hack RFs in the 2.4 gigahertz band, and just transmitting with one and receiving with the other, and just using a directional antenna on each one, and just doing CW, which is sufficient to do what I've wanted to do. But I'm actually starting to experiment with different kinds of modulations. I don't need FMCW. I don't think really gets me anything, because I'm just dealing with trying to pick up a modulation, something that's intentionally modulating its reflection.
Yeah.
But I have been playing with like doing direct sequence spread spectrum type of modulation to be able to pick out the reflection from other interferers.
Mm-hmm.
Because that's been a problem that I've had, is dealing with interferers in the 2.4 gigahertz band.
Like water molecules?
Well, no, I was thinking of things more like Wi-Fi.
That too, yeah.
And like I'm pretty sure. So I did a live demo on stage at DEF CON, where I had one of these retroreflectors implanted in a PS2 keyboard cable. And I was trying to, and so I had one hack RF aimed at the cable and another hack RF aimed at the cable. And I was trying to pick up a return off of it and show that I could decode keystrokes from the cable. And the demo totally failed. And I think the reason that it failed was actually due to RF interference. And since I was using a very unsophisticated method of demodulation, and I'm just looking for, the amplitude of the return, it's very prone to interference. So, and here I was in a room with 1,500 hackers. Go figure, there's some interference. So it'll be interesting to see how it goes doing like a direct sequence spread spectrum kind of modulation, code-based modulation to try to solve that interference problem.
And so why is the spread spectrum stuff better? Is it just because it captures more of the...
It just gives me something on the return side, on the receive side. It gives me a signal to correlate to. So I'm looking only for reflections of my transmitted signal, and I'm picking them out by correlating to exactly what I transmitted, as opposed to what I'm doing now, or what I have been doing, which is just picking up any variations in amplitude. Amplitude could vary for a lot of reasons, and interference is a big one.
Yeah. Do you phase cohere your two receivers? Are they same clock or what?
I can, but that wouldn't have really gained me anything for the particular demo that I did at DEF CON.
Okay.
I'd be curious to know what benefit you think I'd get from that.
Let's see. I think it becomes a problem of it's an interferometric problem now. It's like taking a laser beam and splitting it twice and then looking at the interference patterns. So instead of, I think what you would end up doing is here's what you'd end up getting. I think with that is anything that's not exactly spot on your frequency for a given period of time, an extended period of time, would go away. And if you low pass filter the product of those two, you might reduce your susceptibility to RFI if it's a bandwidth issue. I think that's probably the one thing would buy you.
That's true. Yeah, that's a good point. And it also gives me a little less uncertainty. I mean, when I've done it in the lab and I'm at close range and I'm transmitting a CW signal with one hack RF and then I pick it up the reflection with another, it's usually pretty obvious to me, like, oh, I have to correct the frequency by just this much, and a few kilohertz or something, and then I'm right on, and that's fine. But I have to go through that stage of correction, which would be totally unnecessary if they were phase locked.
Well, the other thing it could buy you is you could look at what you get to view now is not only the amplitude differences but the phase differences as well. And so you can actually, since you're sampling I and Q, you can get absolute phase.
Yes.
You can unwrap the phase. So you might that's got to buy you something, I would think. I would think if you watch the phase over time and then you bandpass filter, so you give it a high pass and a low pass, because you don't necessarily want. You want to always limit as much as you're observing as much as possible. That might buy you something, because I think at the DC at 0 beat, you're going to be picking up every scatterer in the room. But then just above DC, you'll pick up only the scatterers who are being modulated, and I think that would buy you a lot.
That's a good point.
So I don't know. That's why I'd phase cohere them. It's just like it's phase coherence. It's whether it's for the software-defined radios or if it's with playing with lasers, it's all the same. And
effectively, I've done that by high pass filtering after doing a frequency correction in the past. But it's just a lot simpler and automatic if they're already at the same precise frequency and phase. Yeah, it helps. You can do weird, crazy stuff too. You could even do it if it's phase coherent and you have multiple channels, which in your case you have 2 for every hack RF. You might be able to do direction of arrival as well. Yeah, that's something that would be definitely fun to play with. There's also some potential for dealing with doing a more complicated modulation at the retroreflector. And there's a pretty interesting research paper from a year or 2 ago actually on doing like arbitrary quadrature modulations in a backscatter device, which is pretty neat. And something that I'd like to play with. Instead of what I'm doing now is the absolute simplest design that I possibly can for the retroreflector, which is basically just a MOSFET. A MOSFET with an antenna attached. Okay, and it shorts out the antenna if it senses something on the gate or something like that? Exactly. Yeah, and then I just plug the gate into the device or the cable that I want to tap. And is it powered otherwise? No. Huh. No, wow. And that's part of what makes it cool is that it's an unpowered design. Of course, in the use cases that I've played with so far, like tapping a PS2 cable, for example, there's a power source there. So there isn't really a great benefit in being an unpowered design. But yeah, you'd have that for USB too, right? USB cable as well. Yeah, exactly. And so far I've just played with PS2 and USB and VGA. Yeah. And in all 3 cases, there's a power supply available. So a more sophisticated device that uses more power is certainly possible. But I'm trying to approach it from the standpoint of understanding the retroreflector technology and how it can be used in the more general case. And there are certainly use cases where having an unpowered design is particularly useful to someone who might want to implant such devices. Mike's a spy, we know it.
I wanted to ask about the antenna side of things. I mean, are they sophisticated antennas? Because I I imagine that would impact things quite a bit with such sensitive levels, but I really don't know what you...
In my retroreflectors?
No, just on the, like, what you're using for transmitting, receiving. Like, what's plugged into HackRF? I've
been using these log periodic antennas made out of a PCB. The designer of the antenna is Kent Britton. It's WA5VJB. That's his call sign. So if you Google WA5VJB, I'm doing it right now just to make sure I got it right. Yes, that's Kent Britton. He makes these wonderful designs of these PCB antennas, and they're really affordable. They're really good quality antennas for their cost and their size. And so I've been using like his log periodic antenna that's from 850 megahertz to 6500 megahertz. And it's not very big, it's kind of the size of my hand. And I just plug one into each HackRF and point them at the target, and it works great.
I guess I'm thinking of, I guess for the higher frequency stuff too. I mean, the antennas keep getting smaller and smaller, right? And
yeah.
I'm thinking of like
proportional to the frequency, or proportional to the wavelength.
Towers and all that crap, like where it's the huge stuff. So that's quite different.
Well, they don't necessarily get. It's just a matter of how much aperture you want, how much gain you want. It's sort of the thing. And once you get to microwave lengths, it becomes an issue of aperture. You could sort of view it as from an optics standpoint. They still can be big, but they're like a mag light as compared to just a little light bulb emitting in every direction.
So you can club someone over the head with it. Is that what you're saying?
Yeah. Especially with a big dish. Those things are heavy, man.
Well, I mean, so it's embarrassing to say as much, but so I have this little, the USB dongle tuner thingy, whatever, and I've played with it a little bit, but it's like, the little wimpy antenna that comes with it, that's not going to do anything.
No.
And I've just never bothered to upgrade the antenna for it, and it's kind of
Yeah, there's so many
police bland.
Many good options. I mean, the best thing, the one thing that people run into with those little TV tuners is that they typically have a connector that isn't very popular, at least not in the US. Like, I think the most popular connector on those TV tuners is the PAL connector, PAL, because they're sold for TV reception in Europe, and that's that's the popular, that's the old TV,
PAL and
coax.
NTSC, right?
Yeah, exactly. So I would definitely recommend you just find a PAL to SMA or PAL to BNC adapter, because in the US, and if you're looking at amateur radio antennas and stuff, I mean, you're going to find tons of stuff that uses BNC, and you'll find a fair amount of stuff that uses SMA too, like these antennas from Kent Britton. Most of them have an SMA connector footprint on them, at least. So yeah, get yourself an adapter and you can use all kinds of fun antennas.
Yeah, or a box of adapters, or 3 boxes like I
have. Yeah, I used it for a while. I was carrying around New Elect that has been helping me with shipping HackRF units to my Kickstarter backers. They've been a supplier of mine for Realtek dongles for a long time, and they started carrying these PAL to BNC adapters, and they were really cheap. So I would buy like 50 of them at a time and just carry them around when I go to conferences.
Yeah.
And like anybody who's like, oh yeah, I've been playing with these Realtek dongles, I'm like, oh, do you want an adapter? Here you go. And I'm just like handing them out like candy.
Merry Christmas.
Yeah. It's amazing how few people actually had one. Like, everybody I ever handed one to was really appreciative. Like, wow, I can finally use that antenna that's been sitting on my shelf.
That's so cool.
Well, I think the thing is that like the barrier to entry is so low on those things. It's just like, if it sits there, $20, whatever.
Yeah,
that's what it came down to.
20
Not
bucks?
all of us are.
$20?
Yeah, man.
Oh yeah, the Realtek TV tuner dongles.
And so you can there's an SDR platform that works with that then.
Yeah, there's all kinds of software.
I use SDR Sharp, and it's just dial in right into the. I say this all the time though, like, so like just looking at the the real time, was it spectrogram over time, spectrum over time?
Waterfall, FFT.
Yeah, the waterfall,
Yep.
And looking at that, like if I would have had that on my first day of signals class,
Yes.
and you can actually see a waveform, but now in the time domain, and like, I mean, like it's like frequency, but also with time like integrated in it. It's just like, why didn't they show us this crap?
Yes.
You know, like I know that I had to do the hard fighting with the math and everything, but seriously, the math would have been so much more interesting if I knew what the hell was going on.
Yes.
Yep.
And so
yes,
totally
I think signals
agree.
should be project-based. We take Mike's, start with
course.
Mike's kit and do something cool with it. Then dive into the difficult and boring math, and at least you understand why you have to bust your ass to figure it out. Then you swing back around to then do some really cool stuff with Mike's kit.
Then you go back to letting the computer approximate it instead of doing it symbolically.
Well, yeah, I mean, you just as long as you understand the Fourier kernel and a few other things, you can do a lot of damage in signal processing.
So, all the stuff that seems really difficult, like all the hard math stuff in DSP, the more I learn and the more I try to teach people, the more I realize that it's really not difficult. It's just made up of a lot of simple parts, and just guiding people through finding those simple parts in the right sequence has become a great pleasure of mine.
That's good, yeah. Otherwise, you have to use LabVIEW. Isn't that right, Greg?
No, LabVIEW is a different problem.
We were talking about this
altogether.
before the show. So let's hear Greg's LabVIEW confessions here.
Well, first of all, I'm in the most of my work has been proving principles. That's
like
what
algorithms and stuff, or
everything. Actually, more like taking the measurements to prove the physics that we can do what we want to do, that we think we can do what we want to do. And so if your goal is to prove a principle as fast as possible, then you don't want to spend your time, coding the FPGA. Okay.
Right.
You don't want to spend your time even doing what Mike did. Mike's board is very complicated and impressive. You don't want to spend your time making that board. You want to be able to buy something that just works like an appliance and that's well supported. And so that's kind of where, and it has an excellent trigger and can be networked with others and so on and so forth. That's kind of why I think LabVIEW is so attractive to scientists and PhDs, because we can crank up a system in no time. An example of that is my through-wall imaging radar that I built at MIT, and the first one was built actually at Michigan State in my garage. That's a near-field phased array imaging system, and both systems were done with LabVIEW. And they were done really fast, because I think the one at MIT was built in, about 12 months. And the one in my garage was made in, 6 months. And that was facilitated by National Instruments hardware LabVIEW.
Well, I was mentioning last week that my I say I used to work on FPGAs on signal processing stuff, but it was LabVIEW, and then it had like the FPGA converters on board, same kind of thing. And it works great.
I mean, it's not going to be efficient necessarily code and whatnot, but what it'll do is it'll get you to proof of concept really, really fast. I mean, that's kind of the way I look at it. And then if you look at it in terms of industrial automation, people who make assembly lines where they manufacture boards and things and have testers, then that's a whole different paradigm that they're well suited for as well. So, but I also know that the LabVIEW folks, the National Instruments folks, are starting to offer some lower cost platforms that you could even license the design and merge it with your PCB if you want to. They're starting to get their fingers into that stuff, and so there's a lot out there. Yeah.
So what, like you prototype on their system and then you kind of drop it onto it's like a ROM that kind of drops onto an FPGA kind of idea?
No, more like there's something at NI Week a year or two ago where someone was building an imaging, I think it was a medical imaging device. And in the heart of it was a LabVIEW box. And they had like this simplified box where you can put they call it a FAM card, which is basically data acquisition front end. And there's a FPGA sort of back end card. And they're willing to sell you those basically without the chassis that you could just bolt into your system. So you can basically...
So like OEM almost.
Yeah, it's kind of like OEM. So they're it's basically like a slightly more larger, more significantly more expensive version than Mike's card. But imagine Mike's card and you put it into an OEM product. That's kind of what they're trying to do.
Yeah.
So I think that's a cool idea if you need to get something to the marketplace first and you're able to fit it within your cost model. I think the biggest issue for a lot of people, though, is the cost model. Their stuff is not cheap. They put a lot of effort into building it and making it like an appliance, and therefore it's not inexpensive. So, but I think it's an interesting option, especially if you're building some sort of military product or like aerospace product or something like that. Could be a way to get you to the end quicker.
So, Mike, what do you think? Is the HackRF going to be designed into the next smart bomb?
I mean,
but on a serious basis, do you think it'll get designed into other products? Or have you seen it start to kind of get spun out into derivative versions or
Raspberry
anything?
Pi does, for example?
A little bit. Obviously, it doesn't have the popularity of Raspberry Pi, but it's. But there are quite a few people I know who are working on trying to develop something out of HackRF, and what that something is pretty widely varying, which is really cool. I always tell people that the way I know that the project is a success is when I see somebody do something with it that I hadn't thought of. That's super cool to me. So it's going to be used, but in various ways. But and in some cases, it may be people taking HackRF off the shelf and just making something out of it, like just a software add-on.
Like Jared's doing that Shield. So when I was at Hackaday, guys, we interviewed Jared about his the Shield that plugs on or whatever it's called.
Yeah, the PortaPack
screen. Yeah, the PortaPack.
Yeah, the PortaPack is an excellent example of something being built on top of HackRF. Now, of course, Jared was part of the HackRF project from day one. So, this has been kind of an add-on that we've had in mind all along. But then I've got other people, interested in using HackRF for various types of monitoring deployments, monitoring broadcast stations, or just doing spectrum sensing, or doing kind of wireless intrusion detection type of things, all kinds of different applications. And some of those will probably be, people buying HackRF and just building a solution on top of it, and others may be people taking the HackRF design and taking parts of it or all of it and incorporating it into another electronic design, and they can do that because it's open source. But of course, that's a lot of work.
Can it plug into like a BeagleBone? I mean, I know the BeagleBone has like USB on the go, so it can go both directions. But can it do that?
Actually, there's a blog post up. Somebody's already done some HackRF on BeagleBone Black.
Okay, that's cool.
It'd be neat if we could kind of integrate it more tightly, but that's a whole lot of work that no one's done. But you can definitely integrate it over USB, and it works great. Yeah,
it'll be interesting to see that too with with Bunny's thing, with the Novena now having the SDR card eventually.
Right.
Seeing how tightly that's integrated and kind of how that stuff all.
And that's a platform where, one of the things that makes it great is the FPGA.
Right. He's got a Spartan 6 on there, right?
Right. So if you're going to take advantage of the FPGA, if you have some signal processing that you can really use that for, then that's going to be a terrific platform.
What about, so one of the questions we had in the subreddit was HackRF 2. Obviously, people always want the next thing. You just finished one. So, Mike, how about that next Kickstarter?
Yeah.
Oh, boy. It's, people keep asking me about HackRF 2, and it is so far from my mind at this point. Yeah, right. Like, it's been a long road. How about
sleeping, people?
Yeah, exactly.
Can Mike get a rest here?
Just stick with HackRF 1, Mike, and just sell upgrade modules that go to the breakout pins.
Well, actually, that is a very real thing that I would like to do, is kind of develop more accessories for HackRF. Like one thing in particular. One thing in particular I'd like. Yeah, there you go. I have a little design for a tiny little filter and LNA board that just goes in between the HackRF 1 and the antenna. And the HackRF 1 has a little software controlled DC bias on the antenna port. So something that's a low power device can be powered just from that. And so I have a little module that's just for a particular frequency band that just does filtering and amplification just to give you a cleaner signal on that band. And it'd be, assuming it works, which I haven't actually assembled one yet, but because I haven't had time. But assuming it works, it'd be great to have like a whole series of these little devices, just using off-the-shelf, low-cost SAW filters, for example, and just allow people to operate better with their existing hardware.
Yeah, that'd be great.
Then, of course, there's Jared's Portapack. There are various possibilities for antennas. There are various possibilities for add-on boards, like for doing radar stuff, like we talked about earlier,
yes.
or for doing. It'd be fun to have a kind of an oscilloscope / function generator front-end module that just bypasses the RF section and just uses the HackRF as a way to get baseband signals in and out from a computer.
Right. That's kind of like what the Red Pitaya does. There was a platform that did that kind of thing.
Yeah. So stuff like that would be cool. It'd be neat to have an add-on board that does like a VNA function. That would be, and actually it's possible that could be the same board that does radar, maybe.
Yeah, probably. VNAs are actually radar devices themselves.
Right. Yeah. So it'd be neat to have a little add-on board that does kind of both functions. You could use it as a VNA, or you could use it as a radar.
I like to use my radars as VNAs.
Do you?
Yeah. They work really well for that.
That's hilarious.
Yeah, it's phase measurement, phase and amplitude over frequency. And the fact I interned at a company when I was only 16 years old that they sold a product. They built radar systems to measure stealth airplanes. And one of their product lines that they could export from the U.S. was a box that plugged into an 8510, which for those of you guys out there, we may be too young, but I remember vividly the 8510 was the best network analyzer in the world. And they cost on the order of $250,000 if you buy them fully loaded. And anyway, you could.
Is this an HP 8510?
Is that why? It
was just assumed it was HP.
It's not an Agilent, it's an HP.
Right. Well, of course, and it's definitely not Keysight.
What Keysight? What is that?
That's what Agilent is now.
What?
Yeah, you
didn't know that?
You got to get the new stickers.
No,
you didn't get stickers in the mail?
I was just playing dumb. It's so ridiculous.
Okay.
They're HP. Let's all just call them HP. Can't we just do that?
So we were trying to get them to switch over to Bill and Dave's garage shop or something like that.
That's what's next when they diverge again, and they're like, "Well, we got to spin off the when they hey here's what they'll do when they spin off the cheap inkjet printers, it'll be Bill and Dave's garage."
There you go. Yeah.
Or did they already do that? I'm confused. Did they already do that? That was HP.
Not yet.
HP is the one making the cheap computers now.
Exactly. Yeah.
That's the downside. Is that they keep trashing the actual name.
That's terrible, man.
Yep.
That's too bad. Well, anyway, it was an HP 8510, and that was, the best network analyzer ever made, at least at the time, probably still is one of the best ever made. And they had this box. It was like a 3U rack box that would sit on top of it. You'd plug your two ports into that, and you talk to it with a PC, a GPIB. You talk to both the box and the the 8510. And the GPIB, as you remember, could trigger the device. It actually had a trigger line that was probably, I'm sure it had to be 50 ohm terminated or something. And so anyway, you could run the thing off that. It was unbelievable. So they actually would do radar cross-section measurements and antenna measurements with the 8510 as a product. And there's probably a bunch of them still out there somewhere. So
that's pretty cool.
Yeah, you could do radar stuff with the network analyzer. They're great for that.
Mike, I remember the grants that you had been the program you had been working on was Fast Track, right?
Cyber Fast Track, yeah.
And that's over now. Is that right or no?
It's officially over. There's I actually have a little bit of work outstanding left on a project, but yeah, the Cyber Fast Track program helped fund funded in a big way the development of HackRF and also the Daisho project, which is still going on. And if there ever is anything like HackRF2, it's more likely to be an outgrowth of the Daisho project than it is to be an outgrowth of the current HackRF design.
Right, because you definitely need USB 3.0 at that point, right? You'd want that higher
likely
bandwidth.
Yeah, I mean, like what's next after the current design? Like what we're doing now is basically making the most we possibly can out of USB 2.0.
Mm-hmm.
Yeah.
And
better chips doesn't help much because the standard's still the standard.
Exactly, right. Like the only thing we could do to upgrade it a whole lot would be to make it full duplex. but I haven't figured out a way to do that under USB 2.0 power. So it's probably, if there ever is a Hacker F2, it'll probably end up being USB 3.0. And
you could do self-powered and then
we could,
or externally powered and then do like Ethernet or something. You could.
Yeah, you could. But there are already other platforms in the world that are that kind of design, and I'm not necessarily trying to build something that people have done before. I want to try to make things that people haven't done before, and that's what's fun for me. So one thing cool about the Daisho project, I know I mentioned it before, but we have the open source USB 3.0 FPGA core, and that opens the door to some different kinds of designs and things that we've seen before. So I think that'll be fun to play with down the road. But of course, it has the FPGA, which has its pros and cons, as we discussed earlier.
Yeah, it's a challenge, I guess.
Yeah, that's right. You could staff up for that. Just get 10 more programmers on board. And,
sure, no problem.
Just throw some bodies at it.
Yeah,
right?
Throw bodies at it. Parallelize it. They call it parallelizing.
Yeah, there you go. So does that mean though the fast track stuff? So is there other type of funding that you can work on with that stuff, or is that just kind of gone for now?
It's gone for now, but we may see some other programs in the future that have some similarities to it. Hopefully, we will. I think it was a unique program in the way that it was able to fund a large number of small projects from people who typically wouldn't be government contractors. And that was really exciting to be a part of, and it'll be, I hope, it will serve as a model for some future programs.
That's cool.
So we had one other question that I don't even know what the person wrote here, but the person wanted to get your opinion on P25/Tetra and other digital radio protocols. Do you guys know what those are?
Nope.
I've never heard of those.
Oh, I do.
Okay.
Oh, yeah. Okay. I'm looking at the Reddit. So P25 is a APCO Project 25, which is a digital radio protocol for voice communications and low-speed data that's used quite widely by public safety agencies in the U.S. And in a couple of other countries. And Tetra is in some ways similar, but it's popular in Europe. And it's so like the police radios, fire, EMS, as they've gone digital, the way they've gone, at least in this country, has been P25. And that's the protocol that they speak. So you can
make a police scanner then with your machine there.
Sure. Yeah. And there's already open source software that will allow you to do P25 stuff. In fact, I've been involved in their project somewhat. Actually, I know a lot about P25 because it's what I was working on when I was first learning software-defined radio.
Yeah.
Interesting.
I was working for a government research lab that was doing public safety communications research.
Which lab was this?
The Institute for Telecommunications Sciences, ITS. It's a small lab at the Department of Commerce Boulder Labs.
Cool.
Where which is famous for the atomic clock. That's like the main civilian atomic clock in the U.S.
WWV.
WWV and WWVB, those signals originate from that facility, although then they get carried up to Fort Collins to the antennas. And then, so like I was right down the hall from the atomic clock, and I had an incredibly beautiful 10 megahertz signal running through coax through the ceilings of the lab. And it was pretty cool. I mean, that's where I learned pretty much everything I know about SDR and electronics was like while I was working at that lab.
That's awesome.
So I was working on P25 security, and while all the other people around me were working on other aspects of P25, like voice quality and interference and all kinds of other aspects of radio communications other than security. So for me personally, SDR was incredibly empowering because I was going through P25 standards and looking for flaws, security flaws. And if I would find something, it was kind of hard to get people to really take them seriously until I used SDR to actually demonstrate how those flaws would impact a system. And the day that I could go into a room and show people what can happen to your radios, that's the day that people really started to kind of say, oh, maybe we should think about doing something about these flaws. So it's been several years now, but P25 has only increased in popularity, and I think Tetra also, just in different countries. And the question on Reddit is asking specifically about like, are these promoting the cause of SDR? And I don't know that that's really true. For me personally, it was how I got into SDR, but I don't know that those two particular radio communication protocols have anything to do with the growth of SDR. But SDR has enabled some of the equipment that's used for P25 and Tetra, and it's enabled a lot of people who do scanning to be able to monitor Tetra and P25. But on the other hand, those technologies have also enabled encryption, which is relatively new to the public safety communications world. For many, many years, they were running, analog, narrowband FM radios.
Yeah. So it's the one few things I can hear out of my TV tuner dongle is I can dial into the police band and hear it come through. It's
So that's kind of a controversial aspect of using these digital radio systems is can and should public safety agencies encrypt their communications?
Have you guys seen that that new I forget the name of it. It was a smartphone, a Bluetooth smartphone add-on that had like a 400 megahertz radio. It was at the walkie-talkie frequencies, but they basically encrypt it. It's the same kind of, well, not the same kind of thing, but what the hell was the call of it? It was called. You don't know what I'm talking about?
I don't know what you're talking about. I'm really interested to know what it is.
Tell us more.
Yeah.
Tell us more.
Oh, shit.
Are you just making this up
It was a
right
Kickstarter.
Now?
No, I had this great idea, guys.
Wait a minute. You said it was a Kickstarter. Now I'm skeptical.
No, it was a Kickstarter. It was Bluetooth walkie-talkie add-on, basically.
And it ran on like perpetual motion or something? Like that giant capacitor they had on Kickstarter recently?
Go Tenna, here we go. Okay,
Go Tenna.
fine.
Yeah, I have seen this.
Yeah.
Okay, you know what I'm talking now? Okay. Go Tenna. So basically the idea is you tether your phone to this antenna, and then you can have encrypted communication across outside of self-service areas.
Okay.
Basically.
Well, what's the market for that?
Right,
like people
right.
living in their bomb shelters, or what? What are we talking about here?
I think it's probably people that are at festivals. That's probably the one that I think of most. They say like emergency
interesting.
situations, but like, come on, it's probably going to be like kids who want to message their. This is the new tin can type thing, and I'm sure there's other uses as well. But it's walkie-talkie range, but then you have encrypted stuff. You have encrypted channels, so
Right. It lets you do like text messaging on your phone off of the
Off grid.
Off grid, right? Off of the infrastructure.
Like I said, that's interesting. That's like a bomb shelter kind of thing, isn't it?
yeah. I mean that's a lot of what they sold it for.
Yeah.
Is for sure to be. You can text someone in an emergency. Oh no, the zombies are coming to get me. Damn you, autocorrect.
Bring the ammunition.
The zombies are eating my train? No, not my train. My
Right, yeah. I actually looked this up, I don't know, a few weeks ago. I think somebody in the Hacker F IRC channel mentioned it. And I was like, oh, I got to check that out. And I found their FCC registration, like their company registration, but they didn't have any filings yet. So, not that have been published on the FCC website. So, like, I know where to look when they do get published, but they hadn't yet. And so, yeah, it's like a little bridge. It connects to your phone over Bluetooth Low Energy, and which is the new flavor of Bluetooth. And then it connects to another Gotenna over some kind of a VHF link that we don't know much about.
400 megahertz. It was definitely in the exact. It was like basically if you have whatever the open band is for walkie-talkies.
This says
FRS band?
151 to 154.
Okay.
Which there's a name for that band.
It's called the Marine Band, Nautical Band. Because I think the Marine Band is there.
Oh, MERS, Multi-Use Radio Service. MERS. A lot of people don't know about MERS. I first learned about it actually when I was working at the Boulder Labs. I was looking at some research that some college had done.
Yes.
I was actually looking at a P25 implementation that somebody did over the MERS band. It was like this experimental thing, and they did a real over-the-air test, like to cars, mobile test in some locality, and I was like, wow, well, how did you get, what spectrum did you get licensed for this test? And they said, oh, we just use MERS. And I said,
so this isn't
what's
the standard.
MERS?
This isn't standard walkie-talkie. This is like special walkie-talkies.
Yeah. So this is it. It's a particular band that not a lot of people know about, but it has some kind of rules that are a little bit similar to the Family Radio Service (FRS). But it's not FRS. It's a different chunk of spectrum with some slightly different rules. And one of the things that it lets you do is some data stuff that wouldn't be allowed over FRS.
So FRS is
voice.
Is that the walkie-talkies? Okay.
No band FM.
FRS is voice only. Yeah.
See, now that's what I thought it was. So I thought it was on the voice band. That's what I was wondering about. Would be like, you're at a conference or you're at a festival and you're trying to track down your family or something, and then you get all this encrypted crap coming over top of your voice band. That would be
no, a completely different band.
Yeah.
Vague similarities, but in terms of the FCC rules, but it's a different band than the FRS radios.
Yeah, I'm looking on Wikipedia right now. I'm like Greg on CNN right now. I'm basically looking at Wikipedia, and it says 2 watt limit for
2
that.
watts sounds pretty good. 2 watt.
Yeah.
Is it ERP or is it input power?
I'm not sure.
ERP. What's ERP?
Effective radiated power, something like that. Compared to ISO, it's effective radiated power. It's a power density at a given range.
Gotcha. Oh, okay. So that's like what they'll actually do in the lab, kind of thing when they're testing
you might if you've ever seen those Hewlett Packard EMI measurement systems with the standard antennas, they'll tell you in dB. They'll tell you in like watts per centimeter squared or dB watts centimeter squared, and then you.
I haven't seen those. I've seen the Keysight ones, though. Have you seen the Keysight ones?
No. Oh, no. It's terrible. God.
Wow.
Low blow. That's just... gosh.
Okay, go on.
Gosh, that's awful.
Just think your daughter's going to grow up in a world where HP is nothing but crappy commercial level printers,
cost more than the printer.
Back in my day,
HP used to stand for something.
HP made some tonnage. That's
HP
right.
used to stand for something.
HP would break your foot if you dropped
that
it.
flag on Iwo Jima? Well, HP was there.
It's so terrible. It's so terrible that the core of the company, what they started building in the garage is that's the part of the company that's been cast off twice.
Yes.
That's right. Yep.
The meat and potatoes.
That's right.
Oh man, that's terrible.
So yeah, it'll be interesting to show this Gotenna stuff. Though I don't know. It might be be interesting to see it with the Hack RF as well. See what they're doing there. Stuff. But because I wonder, my first question was also they have a frequent asked questions where they talk about encryption and stuff like that. I think they're something AES. Secure. How secure is Gotenna? That's right, because they gave a very lame answer. How secure is it, guys? Very.
Super secure.
That's right.
Well,
Trust us,
can't be
citizen.
any better than that.
I'm still confused about what the market is for this thing. I can't get past that. I don't know who would buy it. I think it's a cool thing, but I don't know what you'd do with it. You know what I mean?
I'm not sure either. I mean, it sounds fun to play with, but I'm not sure like how they're going to sell lots of them. Who they're going to go to?
I mean, yeah. I don't know what you do with the thing. It's cool though. It's a good project.
I'm sure that they're going to sell a lot against preppers and stuff like that. People that are freaked out about stuff.
Right, the bomb shelter crowd. They might be into this stuff.
Maybe,
right.
Or maybe people camping or skiing.
This would be glamping, right?
Glamping. Yeah, exactly.
Well, I mean, let's think
Yeah.
about the con-ups of this. So, I mean, you have a smartphone and then this other thing. So you have two things you have to drag around everywhere when you're on the ski slopes.
Yeah, but it's like some small thing that fits in your pocket.
But that's what the FRS radio's for, or your smartphone.
Well, yeah, but I think what they're trying to do, I would guess that.
Yeah,
okay,
let's
say the skiers. Skiers on the mountain right now might have an FRS radio to talk to the people that they're skiing with and their family back at the lodge or whatever, and then also have a smartphone that they're carrying with them. So why have two devices?
Yeah, they got to take a video of their sweet jumps, right?
I just have one or the other. I mean, usually I only have one. I don't carry two devices.
Well, I'm thinking that there are some people today who do carry both, and maybe that's their target market is people who would rather carry
two devices instead of
one tiny little thing that stays in their pocket, and then one device that they talk on. I don't know. Maybe.
I don't know.
They're definitely looking for people with excess income.
They're looking for people with they're looking for people with deep pockets to put all this crap in their pockets.
That's right.
Fit all this stuff in their pockets. Deep pockets.
But yeah, I mean, it'll be interesting to see this as well. I had never heard of MERS, the band, so could be interesting to see what else is on that band and stuff.
Yeah,
I think I did use my the SDR Sharp, and I went to it and I looked this up. I think, but it was
the big
pretty
recollection that I have is that some people use it for voice communications similar to FRS, but that it also permits some other stuff like digital communications.
Yeah, it's only got 5 channels, so interesting. Well, guys, what else is going on? Anything else? We're what, like an hour and 3/4. We're almost to 2 hours here. So.
Oh my gosh.
Yeah.
How did that happen?
Yeah. Well, Greg's been working up the nerve to start telling us about his job. He's getting there.
No. Yeah. I could talk about my book and book series if you'd like.
There you go.
More books?
It's more books, yeah.
The ones like where you're trying to get everybody else to write books now?
I am. I'm trying to find you, Chris. I think you should write one. It'd be great.
Yeah.
Contextual electronics.
I have like no.
The book form.
No. People are always trying to get me to write books. Mike knows video is where it's at. You can get a lot more across in video.
Yeah, you video's easier in so many ways, and so on and so forth.
It is. I don't know. I have a dream of writing a book someday, but it's like the book that I want to write is still a long way off from becoming a reality.
Yeah.
I feel the same.
It's a lot of work, man. You don't do it if you don't have to, but it's it does buy you interesting career opportunities, but if you already have those happening and you're, just leave it alone. When you run out of other things to do, maybe that's when you pick up the pen.
I don't know, man. Wolf Blitzer ain't called me
yet. That's kind of what enabled that stuff. It really did.
Right.
I could fake being a sonar expert.
Just write a book.
Or a radar expert
All
for that matter. I'll fake anything.
No, you get a lot. It's funny. It does actually open up a lot of opportunities, especially for you guys who are, self-employed doing this stuff. You'd get quite a few, at least opportunities for contract gigs if you wanted them. If you write the book on it,
right.
I get emails all the time about stuff. I don't have time to do it, but
I know.
If I had the time, I could. You could be involved in so many things. It's kind of fun. That's the fun part about it, is really just meeting everyone. If you look at it from the short-term perspective of the few $1,000 you're going to get from publishing the book, then that's really not what it's about. It's about the other things. The second-order effects is why you do it.
Yep.
So, and then the beauty is, if you do it once, you never have to do it again. think about it like that.
I'm sure you get asked
You
to.
do.
Yeah.
Sometimes you start a book series after that,
series,
right?
thank God, no. I actually don't have to write anything in the series. Basically, they just want me to recruit
now you're a
people,
publisher.
who are good,
Yeah.
like you, Chris, to write interesting books.
Talk to Mike, man. Talk to Mike. He's closer.
Oh man, I should.
I'm actually working on a book project.
You are?
But
Oh no.
but it's a very small one because I'm just doing like a couple of chapters in a book that has a host of authors. So
Oh yeah,
nice.
yeah.
I'm actually kind of happy about that approach because it's a book that we kind of all want to see written. And since we have a whole bunch of authors, none of us has to put, the tremendous amount of effort in that you would need to write a whole book by yourself.
Yeah. No, that's if you can do it that way, that's the way to. Are you a chapter author or co-author on it?
I don't even know the answer to that question, but I think I'm a chapter author.
Okay. Yeah, that's a much easier way to go than writing the whole thing from scratch. It's tough. Even if you have co-authors teed up, things happen in people's lives over the 3 or 4 years you might write a book. They may not cross the finish line.
Yeah.
So it's tough, and I don't know. I don't recommend for everyone, but if it's opens up opportunities, it'll definitely does that much.
I don't recommend it for everyone, but people should do it because I need authors.
That's pretty much it, man. Yeah,
That's
that's
good.
fun stuff.
The Amp Hour keeps contradiction alive,
It
folks.
does.
All right. All right, guys. We should let Mike go eat dinner, and Greg can go back to his burgeoning family and his new house and his new life with his
Mysterious
continuing
job.
startups.
Oh, yeah, no.
That's right. International
Can't
man
tell
of
you what
mystery.
we're doing.
So, guys, thanks so much for being on the show this week. It was quite a lot of fun. I probably asked more questions this week than on any other show because I never know what you guys are talking about.
Well,
so
thanks for having us. That was a lot of fun.
Yeah, thanks for introducing me to Mike as well. I've learned quite a bit about SDR, and hopefully it'll be higher on the priority list in the near term to give it a spin.
Yeah, likewise. It was a lot of fun getting to meet Greg.
You guys aren't allowed back until we see a coffee can at Hack RF. So
Oh, jeez.
that's the price of admittance. So. All right, guys. We'll talk to you then.
We can do that. Take care, Chris. See ya.
Thanks, guys.